Hi everybody. I wanted to talk through what I think would be a reasonable thinking process to go through for the remove runs problem. The goal here is not to come up with the most efficient, cleverest, best solution. It's just to come up with a working solution that fits how you might think about doing this as a human being, because we call that a naive solution. Naive because it's kind of the first thing that would occur to us, and that's usually the first step in coming up with a better solution after that. Okay, so for the first step for any problem is you have to understand what the problem is saying. You have to understand, like, for a given input, what would we expect to see as the output. So remove runs, any sequence of repeated digits is going to get removed in the output array. So if this was the input array, the output array should look like, let's see, 1, 3, the 4s get removed, the 5s get removed, the 2 stays, and the 7 stays. So, like that. Okay, so the whole trick with pseudocode is you have to break down what you're doing as a human into steps that the computer can do. So here, I can just see there's a chunk of 2s, but of course the computer doesn't automatically see those chunks. The computer can only compare 2 elements at a time. So what I'm thinking is, okay, I'm going to have my fingers be the 2 elements. I know I want to kind of start at the beginning of the list and go over it. So I guess I'll just compare the first 2 adjacent elements. If they're the same, then I know I want to kind of fast forward until I see something that's different. So let's start trying to get this into some kind of pseudocode. So I want to loop from 0 to the end of the list. And I'll say if the 2 adjacent elements are the same, so if AI equals AI plus 1, okay, so we'll call the array A. So if 2 adjacent elements are the same, then I want to, like, fast forward. So when you're writing pseudocode, like I said, pay attention to what you're doing as a human. So here, I want to kind of zoom forward here and, like, start from here as a new step. So I don't know how I'm going to fast forward yet. I haven't thought about that yet. But we're just trying to sort of rough out the kind of structure that might work. Okay, well, so if 2 adjacent elements aren't the same, then they must be different. So I'd want to add AI to the output array. Something like that. Because I know that if these 2 elements are different, then this one must not be part of a run. Okay, could I also add the second one to the output if these 2 are different? And I think the answer is no, because, like, for example, what if this had been 1, 2, 2? In that case, 1 is definitely not part of a run because it's different than its succeeding element. However, this one is not different from its succeeding element, so it is part of a run. And we couldn't know that until we loop and start looking at the next pair. Here, I'm going to change the arrays back. Okay, so fast forwarding is going to involve setting I, because I is our loop counter. It's going to set I to like whatever the location of the next value is. So here I see 2 adjacent elements that are the same. I'm going to fast forward I until it gets to the location 3. Here I see 2 adjacent elements that aren't the same, so I add 1 to my output array. And now I loop back up and I increment by 1. Here I see 2 that aren't the same, so I add 3 to my output array, and I go back up and increment by 1. Now I see 2 that are the same, so I fast forward I until I get to location 7. And then I start here and I check again. So it seems like that's going to work as long as I can figure out how to do this fast forwarding bit. So I think the fast forwarding bit, remember I is sitting, if we've seen 2 adjacent elements that are the same, I is sitting at the first one. So I think what I want to do here inside fast forward is I want to loop forwards from I, like starting at I, until I see a value that's different than AI. So this fast forward part, I could do something like this. I could declare an integer called next. That would be the location after I. And then I could say something like while AI equals a next. So like while the element that I is pointing at is the same as the element that next is pointing at, I want to keep moving next forward, because that's going to move next forward until I see something different. So then I'll say next plus plus in there. Something like that. So once this while loop is done, I know that my next pointer must be pointed to the location where it's a different number. And so then I can set I equal to next and move on. Okay, so there's a whole bunch of kind of lurking bugs in here, but this is a thing that's roughed out and is probably going to work. So let's take a look at some of the bugs. So I said we wanted to set I equal to the next value, which was the location where we saw the first non-run member. Actually, I think we want to set it to next -1, because remember, as soon as we've fast-forwarded, we're going to loop, and the first thing that's going to happen when we get back to the top is we're going to add 1 to I. So if we had set I equal to next, then when we loop, we're actually going to jump I up by 1, and then we'd be comparing these two elements, and so we'd actually miss that one. So that's one thing. We'd set, excuse me, we got to set I to be next -1. Okay, so other things that we have to worry about. What if there's a run that lasts all the way to the end of the array? In that case, I'm looping by making next larger as long as I keep seeing values that are the same as the run that I'm in so far. So this is just going to run me straight off the edge of the array. So I think inside while here, I also want to say while next is less than array.length. So that should protect me from that problem. What else could be a bug? Okay, I don't see any other obvious ones just staring at this piece of paper. So now what I'm going to do is I'm going to type it up, and then you want to run it on a bunch of test cases, because you can't really know if your code works just by looking at it. You've really got to test it against test cases. This is something I think a lot of people still aren't doing, and it's really going to start hurting you soon. So really, please test. So let's look at what this looks like when I type it up. Okay, you can watch me do it in fast forward. So remember, you always want to create a method whenever you're doing a single logical thing. So public int remove runs, and it's going to take an array as input. And now right away, I'm going to create a new sample array that will be like my test array. So I'm going to do the same one that was pictured in my hands drawing. Okay, there we go. And I'll say remove runs sample. And now I can print out the result to see what it looks like. System.out.println arrays.toString and the result. Great. And it doesn't like remove runs because it's not static. Okay, here we go. So I'm going to really quickly type this in, and we'll see what it looks like. Okay, so let's see where we are. So I've got my input array A. I'm looping from 0 to a.length, and already I'm noticing another bug I didn't spot before. I'm checking the element at I and the element after I. So if I loop all the way to the end here, I plus 1 is going to be off the edge of the array. So actually, I think I want to loop not quite to the end. So if I see two adjacent elements that are the same, I want to fast forward. Well, fast forwarding feels like its own separate command to me, so I made find end of run, because the idea is I'm going to be searching for the end of the current run, the run starting at location I using array A. So I've written that method. Let's just assume that works for the moment. So it's going to give me the location where the run actually ends, and so I'm saving that into I, so that has now fast forwarded to I. And now I subtract 1 from I because the for loop is going to add 1 in the next iteration, so I want to kind of compensate for that. Okay, so now I've discovered we have this issue. How do you add AI to the output array? So I'm supposed to return an array, not an array list. But the awkward part about an array is it's not dynamic. It doesn't, you have to create it with a fixed size, and you can't expand it and contract it. So one thing you can do is, if it's easier to write with an array list, we'll start by writing it with an array list, and then we'll figure out how to adapt it to become an array. So I'm going to make integer, I'll call it output, new array list, integer. Nope. Okay, so now this command is easy to do because it's an array list. So output add I. So a couple things I could do here. If I could only take this array list and convert it into an array before I return it, that would be one possibility. That's actually not so hard, so let's do that. So I'll call ret for return. It'll be a new int, and it's going to be whatever output.size is. And then I'm going to loop over all of the values. 0, I is less than ret.length, I plus. And now I'll say the return value at I is going to be output.getI. So I'm copying each thing from my array list into my array. And now I can return. Okay, this might feel super ugly to you. And yes, it is super ugly. It feels ugly to me too. On the other hand, it worked, right? So that's one thing. A separate thing you could do, instead of using an array list, is something like this. We could create the output array here, and we're going to create it with the same size as the input array. Because we know it can't possibly be larger than this. Like, let's pretend that the input array has no runs at all. Then in that case, the output array should just be the same as the input array. Okay, so now that I've created the output array, I'm going to create a pointer called next free output location, which is going to record where is the next spot in the output array that I'm going to save a number into. So now I can say output next free output location equals AI, and then I'll say next free output location equal plus. So I'll increment the next free output location. Okay, so what am I left over with at the end here? It's possible that I'm going to have a whole bunch of zeros at the end of my array because I created one that was as long as the input array to start with. But what happens if, for example, the input array was one really long run, so the whole thing gets removed? So what I really want to do is now I want to return the actual return array, but I want to create it that's the right size. How do I know what the right size is? Well, next free output location has recorded think about this like a counter. Like I increment this by 1 every single time I save an output value. So this is sort of telling me how many values did I add. So now I can create my true return array. Return equals new int, except I'm going to create it with a size of next free output location. Okay, I'm feeling like there might be an off by 1 error here, so let's think about it. Next free output location starts at 0. Let's pretend the whole thing's one long run, so we never actually do this step. In that case, next free output is 0, so I'd create a return array that's length 0, and that's what I'd want. Okay, so that makes sense. It's all checked out. If you don't do little sense checks like this for yourself, that's another thing you should try and start getting in the habit of doing. To some extent, that's sort of like you'll get better at this with experience, because I know that this is the kind of situation where there might be an off by 1 error. Maybe you don't have that gut feeling yet, and that's okay, but I'm trying to illustrate the sorts of mental habits that you'll start to learn as you program more. Okay, so I've created my return array, so now, same thing. I'm going to loop through the return array, and I'm going to copy values into the return array from this output array that I had up here. So that would also work. I'm going to keep this version like this, because it doesn't use an array list. Okay, so the next step would be you'd actually run it on a whole bunch of test cases. So this is sort of like an expected test case because it's got a reasonable mix of things. You'd also want to test it on a test case that maybe has just one big long run. you'd want to run it on a test case that has all unique values. You want to search for the edge cases. Instead of doing all that, I want to illustrate a totally different way that you could start thinking about this. Instead of trying to pay attention to what you as a human are doing, let's focus in on what's an important concept in this problem. So the idea of the run is an important concept, and the run is a whole sequence of consecutive digits that are the same. So I'm thinking, is there a way to test for these divisions between runs? So I'm thinking, yeah. What I'm noticing is that two adjacent elements are in a run together if their difference is 0, but if the difference between them isn't 0, then that means they're not part of a run together. So what would happen, I haven't really fleshed this idea out yet, but let's pretend, what would happen if I thought, let's loop over this whole array, and I'm going to create a new array that is the difference between the element and its next element. So 2 minus 2 is 0, 2 minus 2 is 0, 2 minus 1 is 1, 1 minus 3 is negative 2, and so on. So 0, this would be negative 1, 0, 0, 0, and then 5 minus 2 is 3, and then 2 minus 7 is negative 5, and then of course this last element of the array we can't do anything with because there is no succeeding member. Okay, how might this be useful to us? So what I'm noticing is any array element here that's 0 corresponds to something we want to get rid of in the original array, right? All these zeros, we'd want to get rid of those elements. However, I'm also noticing that a number directly after a 0 is also one we'd want to get rid of. So here's a number directly after a 0, we'd want to get rid of that. Here it's after a 0, we'd want to get rid of that. So that kind of does it. So a different way to look at this is loop through the array once and create a new array that contains all the differences. Now let's loop through this array a second time, and if we see a 0 followed by another number that's not 0, let's make it 0. Now, every single number that's not 0 in this array corresponds to a number that we'd want to keep. So all we need to do is loop over this array one last time, and whenever we get to a non-zero element here, we grab the corresponding element out of that array. So that would be like a very different approach. It's a little bit less efficient, but maybe it makes more sense to you. And the kind of thing that I'm emphasizing here is there's lots and lots of different ways to solve these problems. But they're kind of puzzles. You have to sit down and puzzle them out, and it's not going to be obvious when you start. It's probably going to take 20 minutes. But that's actually what makes programming fun. So I hope this has been helpful. We'll continue to practice this the whole year because this right here is the fundamental programming skill. This is what you get hired for. It's being able to think independently about problems you've never seen before, and think successfully about them. Okay, thanks so much.